Hi everyone, today I'm going to tell you about the burden on current transformer. Now first of all, what is a current transformer? So the current transformer is used to step down the high currents to a lower or the more manageable level for the measurement and the protection purposes. See that it's the connection diagram of the current transformer. Consists of the primary winding, which carries the high currents to be measured or monitored, and the secondary winding connected to measuring or the protective devices. Current transformers are used in the energy monitoring systems, protective relaying, and the power quality analysis. So now let's see what is burden on the current transformer. Burden refers to the external load connected to the secondary winding of the current transformer. See that it is the secondary winding of the current transformer. So what is connected with it? That is the meter. This is the ammeter. So it is a burden on this current transformer. All the current transformers has a particular burden which is written on them. That is, the maximum load on the secondary side has a limit. Above that we can't connect. On the nameplate of the current transformer, burden voltage is written. To ensure the accurate measurements, it is important to match the burden, that is the external load connected to the secondary winding. In the technical language we call it as burden. So this load can be a variety of devices such as meters, as we have seen that ammeter, resistance of the secondary winding, relays, or protective devices that consume the current signal provided by the transformer. Too much or too little burden can distort the current readings, so it is crucial to match the burden to the current transformer specifications for the optimal performance. Too much or too little burden can mess up how accurately the current transformers measures current. So it is important to have the right amount of the burden to get accurate readings. The burden is expressed in volt amperes, that is VA. The current transformer burden rating as per IEC standard are 1.5 VA, 3 VA, 5 VA, 10 VA, 15 VA, 20 VA, 30 VA, 45 VA and 60 VA. Here IEC stands for the International Electrotechnical Commission. So it is an organization that prepares and publishes international standards for all electrical, electronics and related technologies. Here some standard values of VA is given for the metering and protective devices which is generally connected. For analog it is 1 VA. Similarly you can see this. Let's see the factors affecting burden on current transformer. So the number and types of connected devices, the impedance characteristics of those devices, and the wiring configurations. Also the burden should be within the specified limits provided by the transformer manufacturer to ensure accurate measurements and prevent overheating. We should also consider some of the practical considerations. Like when designing or installing current transformers, it is essential to consider practical factors such as cable lengths, insulation levels, and environmental conditions. These factors can affect the overall performance of the current transformer and should be carefully evaluated to ensure optimal performance. Current transformers are rated to operate within specific limits, so it is essential to match the burden of the measuring instrument or load to the specifications of the current transformers to ensure the accurate and safe operation. The burden of the relays and the meters is given by the manufacturer. Also, the value of the power consumption of the relays, trip coils are given by their manufacturer. The current transformer of the suitable burden can be selected after calculating the total burden on the current transformer. It can be calculated from manufacturer specifications as the burden depends on their type and design. Current transformer current rating shall be minimum 20% more than the applicable equipment rating for the safety purpose. The current transformer of the suitable burden can be selected after calculating the total burden on the current transformer, and it can be calculated from the manufacturer specifications as the burden depends on their type and design. See now how to calculate the burden. So calculating the burden on the current transformer involves determining the total impedance presented by all connected devices. This can be done by summing the resistive and reactive components of each device and accounting for the wiring impedance. It's essential to match the burden requirements with the transformer's capabilities to avoid measurement errors. See, burden can be of the two types, resistive burden and the complex burden. Resistive burden consists of the resistance and it is associated with the devices like ammeters And the complex burden includes both resistive and reactive components commonly found in the devices such as protective relays. The cost of the current transformers are directly proportional to the burden rating. Now let's see how to find VA. So the formula to find VA is equals to I square into R. Here R is the burden or the resistance which is connected to the secondary winding of the current transformer, and I is the current, secondary current. Suppose the burden is 0.5 ohm at 5 ampere secondary current. Its volt ampere is calculated as, we are given current, that is 5 ampere, resistance, that is 0.5 ohm, and by putting these values in the formula for VA is I square into R. So we put I square, that is 5 square, into resistance, we have the burden as 0.5 ohm, multiply 0.5. So after solving we get the VA value as 12.5 volt ampere. So this is how we can find the volt ampere. So thank you everyone for watching.